Okay. Berjaya key in attendance? Dapat key tak attendance? We look at the first subtopic, 10.1, which is galvanic cell. Okay, so I request you to refer to your notes, which I have provided earlier. Okay, so we start with 10.1 galvanic cell. We look at what is electrochemistry. Electrochemistry is the study of relationship between electricity and chemical reactions, and therefore we will learn two important process. The first one is called reduction. The second one is called oxidation. Okay, together we call them as redox reactions. Okay, which shows that oxidation and reduction occurs simultaneously. Okay, and then ini sebenarnya kita dah belajar masa dekat semester 1 when we learn balancing the redox equation. So if you remember, reduction means occurs when we gain electron, substance gain electron, reduction takes place, while oxidation occurs when substance loses electron. And another indication is that for reduction, the oxidation number will decrease, while the for oxidation, the oxidation number will increase. Okay, and particularly for this electrochemistry chapter, we remember that our reduction always takes place at cathode, while our oxidation takes place at anode. Okay, so I'm quite sure you have heard these terms before, cathode and anode. Pernah dengar tak sebelum ini? Cathode dan anode. Pernah Okay, good. So this is when we learn electrochemical cell ataupun kita belajar voltaic cell, even electrolytic cell pun kita ada cathode dan anode. Kita pernah belajar Okay. So example of equation lah, I give you just example macam mana reduction punya equation reduction, sorry. I use black color pen. Reduction reduction equation is Cu2 plus, contoh Cu2 plus equals gain 2 electron become Cu, gain become Cu solid. Okay, this is reduction. Kalau oxidation, let's say zinc solid, then loses electron. Zinc 2 plus aqueous, and it loses electron. Okay, so in this case we can see this one reduction gain electron, and oxidation it loses electron. Okay, and apart from that, kalau nak cerita dari segi oxidation number, you can see here from plus 2 it becomes 0 so dia reduce lah. And then for zinc from 0 it become 2 plus. Okay, plus 2, sorry. So this one you can see increases. So that is oxidation. Ini basic basic of oxidation and reduction. So far okay, boleh faham? Yeah, boleh Okay. That's good. What else we have here? Another term. This one, both of them. This equation this equation is known as half cell reaction, ataupun boleh juga panggil half cell equation. Okay, ini dikenali sebagai half cell reaction or half cell equation. So kita ada oxidation dan reduction. Bila tambah dua-dua ni, kita akan dapat apa yang dikenali sebagai, ada buku panggil cell reaction, ada yang panggil overall cell equation pun ada. Okay, so you can call as cell reaction or overall cell equation. So what will happen when we combine both? Kita tengok di sini, kita boleh cancel electron. Okay, we can cancel the electron. So overall kita akan jadi Cu2 plus aqueous plus Zn solid will get Cu solid plus Zn2 plus aqueous. Okay, So this is called overall cell equation or cell reaction. Sometimes overall cell reaction. Dia ada banyak nama lah. Tak kisahlah. Tapi dia mesti cell reaction atau overall lah. Okay. Boleh dapat half equation and overall cell equation. Boleh ke? Boleh Okay, so saya repeat balik pada slide nombor 1 ni. The important terms anda kena tahu. First reduction, second oxidation, third redox reaction, fourth cathode, fifth anode, sixth half cell reaction or half cell equation, seventh overall cell reaction ataupun cell reaction. Okay, these are the terms, introduction terms lah yang anda kena tahu lah. Okay. Alright, next kita pergi kepada slide seterusnya. Okay. Anda boleh refer pada nota juga. Kita ada dua jenis electrochemical cell. We have two type of electrochemical cell. Two type. Okay. The first one is called galvanic cell. Galvanic cell. The second one is called electrolytic cell. Electrolytic cell. Okay. So our focus now will be on galvanic cell. So galvanic cell, dia punya important things to take note here is about galvanic cell. Galvanic cell, it converts chemical energy to electrical energy. Okay, that's very important. Chemical energy ataupun chemical reaction pun boleh converts to electrical energy lah. Of course, electrolytic cell opposite. Electrical energy tukar jadi chemical energy lah. Okay, that is about electrochemical cell. Yang fokus kita hari ini adalah pada galvanic cell lah. Okay, so when you talk about galvanic cell, you need to know the components. Components of galvanic cell. Also you can refer to your book or your notes. I think I will draw diagram and explain in terms of diagram lah. If you see the diagram, much better lah. You get a clear idea. So you need to have two beakers, right? It should be same size beakers lah. Okay. And then you have electrode. Okay, electrode. Okay, electrode. Also same size. Then they are connected externally using a voltmeter. Okay, they are connected externally. Gunakan voltmeter. And then we have solution. Dia pun ada nama lah, solution. Nanti saya beritahu nama-nama mereka. Okay, and these solutions are connected through an apparatus known as salt bridge. Okay, nanti kita akan label. Kita lukis dulu. Okay, so these are the components, important components of a galvanic cell. Important components of a galvanic cell. Okay, so now we label. We try to label. The top one is known as voltmeter lah. Okay, and then this is electrode, dikenali sebagai electrode. And then this one is electrolyte. Okay, electrolyte. Okay. Okay, electrolyte. And then sini dikenali sebagai salt bridge. Can you see the diagram, guys? Boleh nampak ke diagram tu? So what you need to do now is you have to maybe I write here. Kemudian nanti saya padamlah. Ini dua-dua you kena cari definition. Cari definition. Kita nampak. These two you need to find the definition of electrode and electrolyte. Okay, what is the definition for electrode and electrolyte lah? Itu you kena carilah. Okay, now maybe I take example. Diagram ini for your information, dalam exam minimum markah dia 5 5 markah lah. Okay, So now what I do is I go for example straight away. Saya letak example Okay. So saya akan padam. Saya akan terus gantikan dengan example. Okay. So saya padam. Terus letak example lah supaya anda tahu macam mana galvanic cell ni. How does the galvanic cell looks like? Okay. So let's say I want to use copper electrode. So copper copper solid line, okay, ataupun solid copper boleh, ataupun nak label short form pun boleh. Kalau short form letak Cu bracket S, okay. And then sini electrolyte we have to put the aqueous solution So let's say copper to sulfate aqueous. So 1 molar. Okay, contoh lah 1 molar. And then here maybe we can use a zinc solid. And then here we use zinc sulfate, zinc nitrate. Zinc nitrate lah. Zinc nitrate. Okay, aqueous 1 molar. Okay, contoh. Remember that your aqueous solution should be the soluble salt. Jangan pergi pilih salt yang insoluble nanti electrolyte tak berfungsi. Sebab itu saya kata pergi cari apa tu definition electrolyte. Okay, electrolyte should be soluble salt then only you can produce mobile ions, free moving ions, ion-ion yang bebas bergerak. Kalau dia insoluble, ion tak bergerak lah sebab dia tak larut Okay. Salt bridge ni we got few components. Few salt can be used. Maybe I give you potassium chloride aqueous. Okay, for example, it can be potassium nitrate. Normally yang biasa digunakan saya letak sini potassium chloride lah. Ini biasa popular lah. Potassium chloride aqueous. Okay, galvanic cell. Can you see the galvanic cell? Boleh ke? We look at the component. Normally, you can see the jamboard here. I can see a metal electrode of zinc. Zinc metal electrode is immersed into a beaker containing zinc nitrate aqueous. So dia mesti electrode dan ionnya. Remember that electrode and ion must be there. Okay. Same goes to on my right hand side. We have copper electrode. Okay, electrode dia copper. And then immerse or deep into the copper to sulfate aqueous. And you can see also this electrode and its ion. Okay, mesti ingat whatever electrode you choose, its ion must be there in the solution. Electrode, its ion in the solution. Then only you can make up a galvanic cell, right? And then another important thing you take note here, this zinc electrode and copper electrode are connected by using wire. Okay, wire lah. And then of course we have a voltmeter to detect the voltage generated, right? And then we have a salt bridge to connect the two aqueous solution. This is the basic galvanic cell. Okay. All right. We can see what happened during the operation. What will happen during the operation when we have this galvanic cell. Just a moment. So if you look at the component, I already explained about the component. Maybe we look at function. Especially kalau saya buka file ni, saya tengok the popular question in PSPM is about salt bridge. Salt bridge is one of the popular question. So you can see salt bridge, as I said, the solution inside the salt bridge, example of solution can be potassium chloride, sodium nitrate, what else? Sodium sulfate. Semua ni boleh jadi salt bridge lah. Solution dalam salt bridge. Tapi salt bridge ni memang menghubungkan dua-dua beaker sebelah kiri dan kanan. Now, what is the function of salt bridge? This one you can look at your notes, which I have already uploaded in Google site, ataupun dalam buku yang you beli. You boleh tengok function of salt bridge. Nampak tak function of salt bridge dalam nota anda? Nampak Okey. Saya bacakan Okey. Function pertama adalah maintain electrical neutrality. Okay. Salt bridge help to maintain the electrical neutrality. And then second one, salt bridge completes the circuit by allowing ions carrying charge from the salt bridge to move to half cells. Okay, ini mungkin saya akan terangkan bila kita tengok dekat explanation nantilah. How does it complete the circuit? Okay, so mula-mula kita tengok how does the salt bridge maintain the electrical neutrality. Kita tengok dulu. So kita pergi ke slide seterusnya. Slide number 3. This one I want to explain how does the cell maintains its electrical neutrality. Okay. Kita ambil sebelum tu saya lupa sorry saya lupa nak bagi tahu anode dengan cathode. Okay. In this case, wait I use a different color pen. Okay. Our zinc is anode. Okay. Our copper is cathode. Okay. Later we will learn under electrochemical series, or we call standard reduction potential table. Nanti kita akan tahu macam mana saya tahu zinc itu anode, copper to cathode. Kita kena belajar table tu. Table tu kemudian For the moment, you just follow what I said. Zinc is anode. Anode is negative terminal while copper is cathode. Cathode is positive terminal lah. Just follow that one first. Okay. So bila kita nak buat nak explainkan maintain electrical neutrality ni, we have to know what happened to anode and cathode. So I start with at anode. At anode, okay. Anode is obviously the negative terminal, right? And you must remember this. This one is a thumb rule for electrochemical cell. The process that occurs at anode is always oxidation. Ini selalu kena ingat. The process that occurs at anode is always oxidation. Maksudnya, kita punya zinc solid. Saya dah bagi tahu tadi. Oxidation maksudnya dia akan lose electron. So, electron akan will be loose. Okay. This is at anode lah. At cathode pula, which is a positive terminal, right? Dia proses yang sentiasa berlaku adalah reduction. Remember that, always reduction at cathode. So what will happen? Cu2 plus equals plus 2 electron will become Cu solid. So this is the equation at cathode, reduction equation. Okay. Now what you see here is, first kita tengok one by one. First kita tengok this one happens at anode. Okay. That is zinc dissolves. Kita kata zinc dissolves. Okay. Ataupun corrodes. Ada orang kata corrodes. Dalam BM terlarut macam tu lah, terlarut lah, dissolve terlarut. So perkara pertama berlaku, zinc kita terlarut, dissolves, corrodes then dia akan hasilkan 2 elektron. Okay. So what happen is, ini zinc 2 plus ni akan masuk dalam solution. Okay, kita patah balik ke slide number 2. Dia akan larut. So sini zinc 2 plus masuk. Zinc 2 plus larut. Zinc larut. Dia hasilkan zinc 2 plus. Zinc 2 plus masuk dalam solution. Nampak ke slide number 2 tu? Can you see what I'm doing at slide number 2? Nampak Saya ulang balik. Zinc ini larut, dia hasilkan zinc 2 plus, which enters the solution of zinc 2 nitrate. Okay, I repeat again. Zinc larut, zinc ni, elektron ni larut, hasilkan zinc 2 plus. Zinc 2 plus ni masuk dalam solution zinc nitrate aqueous. Okay, that's the first thing. That's the next thing. Okay, seterusnya, seperti saya kata, dia juga hasilkan 2 elektron. Okay, so what happen is, this 2 electron, dia bergerak melalui wire di luar. Okay, so you can see in the diagram, slide number 2. Saya gunakan warna turquoise lah. Keluar daripada sini 2 elektron. Tak payah letak 2 lah, letak elektron sajalah. Keluar dari sini elektron, keluar daripada sini elektron. Dia lalu sini, dia masuk ke cathode. Boleh nampak ke elektron masuk ke cathode? Okay. Jadi apa yang berlaku di sini serentak adalah beberapa perkara berlaku. Zinc corrodes, dihasilkan zinc 2 plus dalam beaker ni. Pada masa yang sama, elektron keluar melalui wire di luar lah. Dia lalu dekat voltmeter sini, masuk ke cathode copper. Okay. Jadi kesimpulannya di sini ialah, bila kita kata sini Zn2 plus enter, Zn2 plus charge dia apa? Positif ke negatif? What is the charge of Zn2 plus? Positif. Okay, good. So since Zn2 plus masuk dalam beaker ini keseluruhannya sekarang bercharge positif. The whole beaker become positively charged. Reason? Zn2 plus sudah masuk dalam beaker tu. Macam mana Zn2 plus masuk dalam beaker tu? Sebab Zn larut. Bila Zn larut dissolve, kita hasilkan Zn2 plus masuk dalam beaker tu. So beaker tu sekarang keseluruhannya keseluruhannya adalah positif. It's a positive beaker. Okay. Now cuba kita tengok sebelah kanan, copper pula. Apa yang berlaku? Okay. Kita patah balik kepada slide number 3. You see what happened Right. Soalan pertama yang kita harus faham adalah, ini Cu2 plus datang daripada mana? Okay. So you kena tahu Cu2 plus ni datang daripada CuSO4 aqueous yang berada dalam beaker tu. Okay. Ataupun kita kata daripada solution. Okay. Cu2 plus comes from the copper to sulfate aqueous which is inside the beaker, the solution lah. Okay. So you try to imagine, kita patah balik diagram tadi. Kita cuba bayangkan. Sini ada Cu2 plus. Okay. Kemudian Cu2 plus ni keluar daripada solution pergi ke elektrod. Ini saya cakap dalam bahasa kasar Cu2 plus ni keluar daripada solution masuk ke elektrod. Secara kasar lah idea dia. One more time, Cu2 plus from the solution masuk ke elektrod. Dia bukan masuk ke elektrod, kita tak kata masuk lah, masuk tu bahasa kasar lah. Kita kata Cu2 plus reduce. Okay, reduce Kalau anda tengok, betul tak? Cu2 plus reduction. Cu2 plus reduction. So, Cu2 plus daripada solution ini, dia akan reduce, maksudnya dia akan masuk ke elektrod ni. Now, soalan saya ialah, di sini copper to sulfate ni, kita ada Cu2 plus sebagai cation, kita ada SO4 2- sebagai anion. Now, soalan saya ialah, kalau ini asyik keluar sahaja, apa baki yang tinggal dalam beaker tu? Apa dia? Boleh ulang tak? SO4 2-. So charge dia positif ke negatif? Negatif, very good. So beaker di sebelah kanan seolah-olah bercharge negatif. Dapat ke idea tu? Okay, saya ulang balik sekali lagi Kita tengok saya ulang balik. So Cu2 plus daripada solution, iaitu daripada copper to sulfate ni. Okay, Cu2 plus daripada solution, iaitu daripada copper to sulfate ni, dia akan reduce masuk ke elektrod. Okay, reduce masuk ke elektrod. Jadi semakin lama Cu2 plus semakin berkurangan, sebab dia asyik masuk je, masuk ke elektrod, reduce ke elektrod, reduce ke elektrod. So kuantiti Cu2 plus ni semakin berkurangan. Dan kita dapati dalam copper to sulfate kita ada Cu2 plus dengan SO4 2-. Kalau Cu2 plus asyik berkurangan, baki tinggal apa? SO4 2- kan? Betul tak? Betul. SO4 2- ni charge ni nampak tak? Charge apa
Negatif.
Negatif. So, beaker sebelah kanan seolah-olah bercharge negatif. Setakat ni boleh ikut? Setakat ni boleh ke?
Boleh, sir.
Boleh Okey, maksudnya pemahaman kita ialah beaker sebelah kanan bercharge positif. Beaker sebelah kiri bercharge positif, beaker sebelah kanan bercharge negatif. Okey. Kalau perkara ini berlaku, kita punya electrochemical cell akan berhenti berfungsi. So kita tak boleh biarkan build up of positive charge, build up of negative charge. Kedua-dua ni tak boleh dibenarkan. Cannot be allowed. Saya tulis sini Ini dua-dua cannot be allowed. Kalau kita benarkan kedua-dua ini berlaku, iaitu build up of positive charge and negative charge, nanti kita punya electrochemical cell stop berfungsi. Maksudnya, saya kena hapuskan kedua-dua ni. Saya tak nak build up positive charge, saya tak nak build up negative charge. So, apa saya perlu buat? Di sinilah function kita punya salt bridge berfungsi. Okay? Dalam salt bridge kita ada K plus dan Cl negatif. Betul tak? Dalam salt bridge kita ada K plus dan Cl negatif. Betul ke? Betul. Jadi apa yang akan berlaku adalah ini Cl minus akan bergerak masuk dalam beaker ini. Cuba bayangkan Cl minus bergerak masuk dalam beaker ini, apa akan berlaku pada positive charge? Positive negative akan jadi apa? Can they cancel each other? Can. Very good. So Cl negatif ini akan masuk dalam beaker yang bercharge positif ini, dia akan batalkan positif. Okay? Sama juga K plus ini bercharge positif masuk ke dalam beaker ini, dia akan cancelkan negative charge. Dia akan cancelkan negative charge. Maka electrochemical cell berfungsi seperti biasa. Because we stop the build up of positive charge, we stop the build up of negative charge, the electrochemical cell function as normal. So what happen bila saya keluarkan salt bridge? You can imagine bila kita keluarkan salt bridge, positive charge sebelah kiri semakin bertambah, negative charge sebelah kanan semakin bertambah. Tak ada orang nak neutralkan dua-dua ini. There's no one to neutral both the charges. The electrochemical cell stop. That means voltmeter akan menunjukkan bacaan sifar. Tak ada electricity generated. Okay or not, guys? Cuba recall balik. Ada soalan tanya dengan saya? Boleh tengok sambil tu, boleh tengok nota juga.